Here's the bell problem for 1.3. You're going to talk about a job that you worked during summer vacation, and it is two jobs. You're walking dogs and you're working at a hair studio. You walk 3 dogs several times a week, and you also work part-time as a receptionist at a hair studio. You earn $8 per hour as a receptionist and $20 per week per dog. Your weekly schedule shown below is the same each week. How much will you earn in 10 weeks? And you have to explain why. Okay, so we first, how about you figure out by yourself and come back and see if we got the same answer. Alright, so it tells us that we walk 3 dogs and we get $20 per week per dog. So for our dogs, we earn $60 for dogs. Then we have to determine how much we make. This isn't showing up. We have to determine how much we make when we work at the hair studio. Okay, and we earn $8 per hour when we work at the hair studio. So on Monday we work 4 hours. Tuesday we work 4. Wednesday we work 4. Thursday 4. And Saturday 4. Okay, so if we add up all these hours, 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. So if you take 20 hours times our $8 an hour, we get $160. Okay. So in 1 week, if you add those up, 160 plus 60 is $220. So that's for 1 week, but the question asks us, how much money do you make in 10 weeks? So what you have to do is take your total for the week, multiply that by 10, or all you have to do is add a 0, so we make $2,200. Alright, so we're starting with 1.3 algebraic expressions. By the end of this lesson, you should be able to evaluate and simplify algebraic expressions. A couple vocab words. A term. An expression that is a number, a variable, or the product of one or more variables. So if I wrote out the equation, 3x squared plus x minus 6, and I asked you how many terms are in this expression, you would say 3. We have 1, 2, 3 terms. Terms are separated by our mathematical expressions, the plus and minus. Okay, a coefficient is the numerical factor of a term. So if I gave you 7x, and I asked you what the coefficient was, you would tell me the number out front of your variable, which is your coefficient. Your constant term is a term with no variables. So if we go back up to my first expression, 3x squared has a variable, x has a variable, but our last term, 6, does not have a variable. So that would be our constant term. And then we have like terms. They have to have the same variables raised to the same power. So if I had x squared plus x, we would not be able to combine those two together because they both are x's, but one is raised to the second power and one is raised to the first power. They have to be the same variable raised to the same power to combine them together. So our first example, we have to be able to write an expression from a given word phrase. 7 fewer than a number t. So when you think of fewer than, hopefully you think of minus, and it's fewer than a number t. So that means we start with t, and it's fewer than 7 fewer than that number t, or that variable t. So our answer would be C. The next one I want you to try by yourself. Which algebraic expression models the word phrase 2 times the sum of A and B? So pause this presentation, come back, and hopefully you have the same answer as I do. Welcome back. 2 times the sum of A and B, meaning A and B are grouped together and we're multiplying that. 2 times means multiplication, or parentheses, so that would be H. Our next one, we start with $20 and save $6 each week. What algebraic expression models the total number that you save? Okay, so if we start with 20, we're not going to add a variable to that because we just start with $20. That doesn't change. But what does change is our $6 each week. So if they asked us after how many weeks, how much money do you have, we could figure that out easily. If we add, because we're combining all of our money together, 6x, because x would be each week. 6 is our coefficient, if you remember from your vocab words, and we have to multiply them together because we earn $6 each week. So if I asked you after 4 weeks, how much money would you have, you should tell me $44, because we plug in 4 here, which would give us 24, and add 20, and we get $44. These next ones are very simple. What is the value of the expression for the given values of the variables? And we have 7a plus 4 plus 3b minus 8. Notice how they give us the values for a and b, so it's really simple. If it helps you, rewrite this expression and take out the variables and replace them with parentheses. So I see an a, replace with parentheses. And I see plus 4. And we got to end the parentheses. That's what our equation starts with. So plus 3. But then I see a variable. So replace that with a parenthesis. And then we have minus 8. Okay, my first parenthesis here, if we look back at our original equation, is an a, which is negative 4. So replace our a with negative 4. Moving right along, our next parenthesis is a b, and replace that with 5. Easiest way to do this is type in your calculator exactly how you see it, and you should get 7. Okay, so you guys try b. Notice how we have a fraction, so be careful. But if you type it in your calculator exactly how you see it with parentheses, you should get the correct answer. So go ahead and rewrite your equation without the variables and replace them with parentheses, and come back and we'll go over the answer. Alright, so once you plug in 1 for x and 1/2 for y, you should get 3/4. Notice how I read it as a fraction. I did not write 0.75 because I do not like decimals. And this is the same thing. What is the value of the expression? Just because you have a fraction, don't freak out. Just because it's raised to the second power, don't freak out. Again, just rewrite it. Wherever you see a variable, replace it with parentheses, and you still have to square it when you plug in 6 and negative 3 for your x and your y. And when you plug that in, you should get 18. Should get 18. Okay, so make sure you're working through these and coming in tomorrow if you have any questions. This next one, we talk about a real-life example. We're talking about a football game. A touchdown is worth 6 points. Our extra point is 1 point, and a field goal is 3 points. We have to write an algebraic expression that models the total number of points that a football team scores in a game. So what I'm going to do is I'm going to have 3 variables, since we have 3 different types of points values. I'm going to make x our touchdown, y our extra point, and z our field goal. So if we're writing just a general algebraic expression, since x is our touchdown and it's worth 6 points, we would put 6 as our coefficient and put our variable right after it. And since we're scoring points, we're not subtracting them, we're adding them up. And remember, y is your extra point, which is worth 1 point, so we just add a y. And you can write 1y if you like, doesn't matter, same thing. And the last one is a field goal, which is z, and that is worth 3 points. So our algebraic expression that is formed is 6x plus y plus 3z. Then they give us some scenarios. Say a team scores 3 touchdowns, 2 extra point kicks, and 4 field goals. How many points did the team score? Notice how they give us values for all of our variables. So again, rewrite this expression without the variables and replace them with parentheses. Type it in your calculator and you should get the correct answer. Pause this and figure it out. Alright, so after scoring 3 touchdowns, 2 extra point kicks, and 4 field goals, the team had scored 32 points. Alright, next, simplifying the expression. This will be looking for common like terms. Remember, common terms have to have same variable and same power. So when I start these off, I look at my first term, 7x squared, and I look to see is there any other terms in my expression that have the same exact variable raised to the same power. So if you look at the next term, it has a y, so that's not the same. Y again, and then we have x. Okay, so we first looked, are they same variables? Yes. Are they both raised to the same power? Yes, they're both raised to the second power. So I will both box them in and combine them together. When you combine them together, all you do is take the numbers out front, your coefficients, and use the mathematical term that is being used. So it'll be 7 minus 4, so we get 3x squared. You don't do anything with your variable. The variable stays the same, and so does your power. Okay, so we combine those together. Those are done. Then go back, look at your next term. I would circle it or do some other type of grouping. And we have y to the second power. If you notice how this other term also has y to the second power. So we combine those two terms together. Again, add up your coefficients out front. So we get plus 5. And you keep your variables the same, y squared. And this would be the simplified version of our expression. Okay, looking at B, hopefully you notice you have parentheses, and hopefully every time you think parentheses, you think distribute. So you distribute your negative through into that parenthesis, and you distribute your 2 through this parenthesis. When you distribute through, you should get negative 3k minus m over here we should get plus 2k minus 8m. Okay, take a moment, see if there's any like terms, combine them, pause it, come back, and see if we have the same answer. You should notice that we do have like terms, and you should get negative k minus 8m. Again, that was negative k minus 9m. Okay, again, work through these, combine like terms if possible. So pause it, come back, see if we get the same answers. So for A, you should get negative 3j squared minus 7k plus 5j. So A again, negative 3j squared minus 7k plus 5j. And for B, you should get 12a minus 53b. Again, 12a minus 53b. Now, this is the end of 1.3. Come to class prepared to work on the 1.3 worksheet.